Hamish, but a lot of people sometimes they like to call me 25 material, you know. I'm Hamish, but a lot of people sometimes they like to call me 25 material, you know what I'm saying? So, no more waste time. We don't want to waste your time, you know what I'm saying? If you fail here, because a lot of new ones here, okay? You come right here, you subscribe, and then we get started. What we have to do. So now this is suppose a function of f and g, I define it by, so this is f, this is exponential function, and these are not exponential function, respectively. Now let's explain the steps of the transformation process that you'd apply to the graph of g to obtain the graph of f. Okay, so what should I have to do in here to come here? Easy. So that's what you do. You know what I'm saying? Okay, g of x, so this is g of x. We want to make, so let's take out g of x. So this is, excuse me, 3x, this is g of x. Okay, so now look, see, it's the same thing but the plus by 3. So mathematical, when you in a position of x, when you plus 3 means, remember, this is x is horizontal, okay? X is horizontal. So when you plus 3 means you move to the left. It's crazy. You know what I'm saying? Means when you plus, is move to the left. It's like you say other way around. You know what I'm saying? So when you plus means this graph, this g, for it to be plus 3 means it was moved 3 units to the left horizontally, and then but for y, no. This is y, this is represent y, this one here. You know, or horizontal asymptote, you know. So if you see negative for y and x, for negative means it was moving down 18 unit vertical down. You know what I'm saying? So we're gonna say, oh, how are we gonna say here? Since the plus 3 from here to here, so we're gonna see it was shifted 3 units. Just shifted 3 units horizontal to the left, horizontal to the left, horizontal to the left. Okay, to get this, and then to get this, so for x, when you see plus means you're moving to the left, but for y means, for y if it's negative, look like this, it's like other way around. For x, if you see x, if something with x, let's see here, plus 3 means just moving to the left. It's like other way around, right? But for y, it's different case. If you see negative means it's just moving down, as you see. If you see positive, it's just moving what? Up. Okay? So now for this case, now we're going to say, oh, so there's a negative here. You know? So we're going to say, it was shifted. Okay, so we say, to get this graph here, finally, means it was shifted, or it was moved, the graph was shifted, or was moved or shifted. How many units? 18. To vertical down. So this is represent y. So for y, if you see plus moving up, when you see negative moving down. But for x, like another business. You know what I'm saying? If you see positive, move to the left, because we expected positive must be here. But for x, if you see positive, say move to the left. Excuse me. When you see negative, say move to the right. You know. So 18 units to there. Vertical downward. The graph was shifted 18 unit vertical downward. Why? Because of the negative. To get from here to get to negative, vertical downward. You know what I'm saying? So yeah, that's it. Okay, for example, how if it was like this? Let's say it was 3x minus 5 and then plus 7. So how are we gonna move this to get this? You know what I'm saying? Let's say this is g of x, and let's assume this is f of x. So how are we gonna say? Since it's negative, I'll say the graph was shifted horizontally because it's x. It was shifted what? 5 units to the right, horizontal to the right. You know what I'm saying? Because it's negative. You know what I mean? So for x, it's just like you see other way around. But for y, for this to come here or to get this, so since it's positive, it was shifted what? 5 unit vertical up. If it was negative, 5 unit vertical down. know what I'm saying? So just a little trick, only for x. If you see positive, you say to the left. If you see negative, say to the right. It's like you say other way around for x. It's simple as that. You don't have to even to stress or whatever. Okay. Number 2, write down the set that represent domain and range of the function f. Okay, this is f. Is easy, man. Whenever you have exponential function, any number can work in an exponential function. So the domain are all real number. You know what I'm saying? So domain are all real number. Okay. So 1.2, domain are all real number. So 1.2, you can say domain of f, right? Domain of f, yeah, domain of f. You can write like this, are all real number. If you don't write like this, you can say domain of f. You say x are element of real number. However you want, then you put curly bracket, or if you don't write like that, you can say from domain of f equal, and they say you can say start from negative infinity to positive infinity, because are all real numbers. So 8 of these you can use. You know what I'm saying? You can use either of these is acceptable. But here must be, excuse me, here must be x are element, because it's domain x are element. So you can write like this for real numbers. You know what I'm saying? All of them. So that's how you get domain. And then other things, how do they say? Domain and the range. Okay, the range for exponential function, if somebody give you, let's say, no, let's do straight away that one. So this is f of x equal to 3x plus 3 minus 18. So what does that mean? Roughly, this graph, we say, is going to start from negative 18 somewhere here. You know what I'm saying? That's the horizontal asymptote. This is the value of horizontal asymptote. Means horizontal asymptote is this value, which is y equal to negative 18. But this graph we know is going to go up because look, it's positive. So it's going to be like woo or woo. We're going to see very soon how it's going to go. Either it's going to go this way or this way. I'll show you how it comes about, okay? But we know it's going to come, but it's never going to touch this asymptote. So in other words, the range is all the value which above this graph. You know what I'm saying? Because range is the value of y, but it should not touch this asymptote. So we're going to say our range is going to be, so you can say range here, range of f equal to y are element, but it starts from negative 18 but excluding. What does that mean? It means it should not touch this asymptote. So this means excluding this. This means including. Oh, okay. So we're going to say excluding negative 18, but all the way to positive infinity. To positive infinity. Okay. But I have a video where I explain domain and range, like the whole tropic to tropic. You know what I'm saying? If you want to have like more example, you can go to my other video. You know what I'm saying? So for now, say okay. So now this range is going to start from negative 18, but asymptote, the graph will never touch asymptote. Means let's say for example this graph come like this, roughly, right? You're never going to touch this asymptote, or let's say you come like this, you're never going to touch this asymptote. Excuse me, sorry, I did touch extension. So you see what I'm saying? So yeah. So our range means the value of y. You know. So if you look here for this graph, it's going to be like, it's only stuck here. Start from here all the way up. It's covered everywhere up. So those are our range. Now, so range, another way you can say the range of f, right? I think range of f, yes. You can write either, you say y are element, but I start from negative 18, but it's excluding, means it does not touch negative 18 all the way to positive infinity, because this graph goes all the way to positive infinity. You know what I'm saying? If you want to write like this, you can say, oh, y are element of real number, whereby this y must be greater than negative 8, means does not touch, because when you say like this, means including, means start from negative 8, but it does not touch negative 18, excuse me. That's why I have to say negative 18 excluding, or you can write like this, like that. And if you want to write in this format of set Buell notation, make sure you write your bracket. So we have a domain in range. Number 3. Write down all transformation ready. Represent domain in range of the function f in equation of the asymptote. Oh, so equation of asymptote, they want this. So for any exponential, we only have a horizontal asymptote. Asymptote is this value here. That's the asymptote. So equation of asymptote, okay, so these, so either you can write like this, for domain, or this, or this. For range, this. So this is not part of the answer. This is your answer here. So this is range. And this is domain. You know what I'm saying? So this is, I was just showing you, but it's not your answer. You know what I'm saying? This is not your answer. Okay, now asymptote, equation of asymptote. We have a horizontal asymptote, domain range. Now we have a horizontal asymptote. Oh, okay, right here. Horizontal asymptote is this value here. -18. Horizontal asymptote. Any number which is in here, asymptote, which is the value of y equal to -18. Okay, cool. Now let's go for the next one. Excuse me, so. Okay, the next one they say sketch the graph, so we have to draw the graph. So now I need some of this information. You know what I'm saying? If I'm going to draw a graph. So how do we draw a graph? They say sketch the graph, and the asymptote represented by a broken line. You know, means you have to draw a graph which you have to involve asymptote, label the horizontal, vertical, asymptote, x and y intercept, if they exist. So look, this is very, very important. When you want to draw a graph of this, you must get, okay, I'm going to list the stuff that you have to have if you, so I'm going to erase this stuff because I don't need them. So this is 1.2, we're done. Let's go for 1.3, drawing the graph of exponential function. When you draw a graph of exponential function, this is the thing that you need, okay? Drawing the graph. Sketch the graph. Sketch the graph. This is 1.3. Sketch graph. Sketch the graph. Okay, what are those things I need? Okay, let's highlight all of them. These are things I need. The first one, asymptote. If it's exponential function, we need to have a horizontal asymptote. Horizontal asymptote. Okay, do you have a horizontal asymptote? Yes, of f, which equals -18. Go to y, -18. Okay, now, another thing you need, x and y intercepts. Okay, let's start with the y intercept, or x, it doesn't matter. Okay, let's start with the x intercept. When x intercept, we know y equal to 0. So it's like saying, when x intercept, y equal to 0. So we're going to take this stuff and put it here. So y equal to 0. So we're going to say 0 equal, because y equal to f of x means 0, equal to 3 plus 3 minus 18. So what happened? This -18 is going to go over. So I say positive 18 equal to 3 x plus 3. So this mathematically I can split to say 18 equal 3 power x and then multiply by 3 power 3, which equal to, it's going to be 3 power 3, means this for the first one and this for the second one from the law of exponential. So this is 27, so it's going to be 18 equal to 3 power x times 27, divided by 27, divided by 27. So divided by 27, this divided by 27, so this and this cancel. So 3 power x equal to 18 over 27, okay, 18 over 27. Okay, how many 9? There are 2 9 here, 2 over 3. 9 is a common number, divided we get 2, divided by 9 you get 3. So 3x equal to 2 over 3. You know what I'm saying? So that's going to give us the x-intercept. So 2 over 3, okay, 2 over 3, plug in the calculator. Okay, so 2 over 3, plug in the calculator. 2 divided by 3. Okay, it's going to be 0.6666, okay, not. Let me show you something here, very, very important. Okay, let me show you something very, very important. If you have, let's say 5, this is not, it's not part of the solution. 5x equal to 2. How are you going to get the value of x? Oh, it's kind of confused. Easy. We know if somebody give you 2x equal to 8, this is easy because I'm going to say this, let me say 2 power x equal to 2 power 3. You see? And when the base are the same, means I'll say, oh, base are the same, x equal to 3, because base are the same. Means I'm not going to focus on this, say x equal to 3. It can be any number, you know, it could be 3 power x equal to, let's say, 81. Now, so this is 3 power x equal to, what is 81? 3 power 4. So base are the same. If base are the same, means x equal to 4. You know, but this is different case now. You don't have a common number here, like say 3 power something. So what you do in this case, for you to get x, you must apply logarithm both sides. You know, that's the only way you can get the value of x. So we're going to apply logarithm, apply log, apply ln, excuse me. Ln could be more easy because you can plug in the calculator. Log or ln, but I'd rather go for ln because it's going to be easier to plug in the calculator. Ln of 3 power x on both sides, 2 over 3. And then after that, you know, this x is going to go to the back, so it's going to be ln of 3 equal to ln of 2 over 3. I want to get the value of x divided by ln of 3, divided by ln of 3. So divided by ln of 3, and then divided by ln of 3. So I'll check my calculator and get the value of x, intercept. Let's check the calculator. Okay. Lean, some people say call lean, some people call ln. I don't know. I always call lean, ln, it doesn't matter. 2 over 3. Okay, ln of 3. And then ln of 3. Okay, negative 0.36. So negative 0.369. So it's like negative 0.4. Okay. So we get the value of x equal to negative 0.369. 369, but when you approximate, for the most cases, I always advise most of the students or learners, if you want to draw a graph, take one decimal place. You know, it's going to make your life easier when you draw. So this is going to say negative 0.4. Only in a graph, but in normal mathematical, always take 2 to 3 decimal place. But for graph, this will make it easy. Oh, so for that case now, I have my x-intercept, you know, meaning my x-intercept, if this x equal to is negative 0.4, y equal to 0. So I'll say my x-intercept, because I want to get x-intercept. I'm going to say, oh, so my x-intercept, when x equal to negative 0.4, value of y equal to 0. So now I do for y-intercept. You know what I'm saying? This is a part of solution 2, okay? All of this is not. Okay, so you need this just in case if you have a question solved. So we had the x-intercept. So now let's do the same thing for y-intercept. So I'm going to write here my x-intercept. Okay, I'll say, okay, my x-intercept by negative 0.4 and 0 is x-intercept. Okay, cool. I need a space, that's why. But you need to write all of this in exam. Okay, now, oh my God, horizontal asymptote erased by mistake. But no problem, I'll write again. Horizontal asymptote. So my horizontal asymptote. Horizontal asymptote equal to y, which equal to negative 18, which is that. Now we want to go for y-intercept now. When y is intercept, now x equal to 0. This is for y-intercept. Okay, when y-intercept, x equal to 0. Let's go to the question. So now we're going to say now when y-intercept, so it's going to be 3, x equal to 0 is going to be 0 plus 3, and then minus 18. Okay, 0 plus 3 equal to 3. So 3 power 3, because it's 3. 3 power 3 equal to 27. 27 minus 18 equal to, come on, I forgot the times table, man. I forgot the plus minus. Where is grade 1? Can you help me now? I forgot. 27 minus 18 equal to 9. Okay, 9. So now we say, oh, when x equal to 0, y equal to 9, and this is y-intercept. So for me to draw a graph, I need to have an x-intercept, y-intercept only if they exist, because sometimes they don't exist. It depends, maybe one might exist, one might not exist. You know what I'm saying? So the more question, you gotta do a lot of question. You can go to my other video, I have a lot of question for these types of when the intercept exists or does not exist. So y-intercept, what is a y-intercept? When x equals to 0, y equal to positive 9. Now we can draw a graph. Let's sketch a graph now. So both x and y-intercept does exist. Okay, now let's sketch a graph now. So you sketch a graph, I'm going to say, Okay, now let's sketch a graph. Okay, so asymptote, always start with the asymptote. So negative 18. Okay, let's say this is negative 18. So asymptote always go by, remember it's y, horizontal asymptote, by dash dash. Okay, so which is y equal to negative 18. Okay, cool. Now let's go for the next one. Okay, now the next one, x-intercept. Do you have x-intercept? Yes. What is the x-intercept? Negative 0,4 and y equal to 0. Okay, these are x-axis and this is y-axis. Okay, so let's say this is negative 1, let's say this is negative 2, rough sketch. So negative 0,4 is somewhere here. You know what I'm saying? If let's say this is negative 1, so this is negative 0,4, let's say this is negative 1, negative 2. This is just rough sketch. Negative 1, excuse me. Negative 2. Okay, now y-intercept equal to 9. Oh, so this graph is going to cut at 9. Let's see. Oh, it's going to cut, let's say this is 9. Let's assume this is 9. Because this is 0. You know what I'm saying? So let's say this is 9. This is a rough sketch. 9. X equal to 0, y equal to 9. Y equal to 9. Oh, so this is how a graph is going to go. But this graph, look, it already show you how it's going to go. It's going to go this way. But it's not going to touch this asymptote. Oh, so now my graph is going to go this way. And then it's going to come all the way. But it's not going to touch the asymptote. And then you can just go forever. Oh, so this is a sketch of this graph with all the intercept and asymptote. Negative 18. Negative 18. You know what I'm saying? Negative 18. Okay, so this is how you draw. And when you finish, don't leave like that. Make sure always you allocate by saying this graph is the graph of this function, which is f of x equal to 3x plus 3 minus 18. You know what I'm saying? Minus 18. So we're done with it. You know what I'm saying? Now we want to go for the next one. So I can erase because we have the information. Make sure you show all the intercepts and everything. And there we go. Now, let's go for the next. So let's say determine the question of it. Define the inverse of function. Oh, okay. So inverse of function. So inverse of function. Excuse me. Okay, let's get inverse function. It's easy, man. So inverse, the game is easy. What you do, you replace x, the position of x, you write y, the position of y, you write x. That's how you do the inverse of function, okay? X become y and y become x. So the one inverse of the function, okay, so we go f of x given equal to, or you can say y, because remember we're going to replace y and x. When you say f of x, it means y. So say just y equal, okay, 3x plus 3 minus 18. Okay, so now I have not started yet to write the inverse. But for inverse, okay, because remember this is like f of x. So for inverse, you see this position of y? This y is going to become x. Means replace what? Y with x. So you can say y with x. Okay, let me just do it. Excuse me. I'm not supposed to write this. Okay, for inverse, when you say inverse, this is going to become x now. And this is going to be 3. This position of x is going to become y. And then plus 3 and then minus 18. So now make these y subjects. And that's going to be your final answer. So what we're going to do, this negative 18 go over. It's going to be x plus 18 equal to 3y plus 3. You know what I'm saying? So we say before, whenever we have something, a number with power, if you want to get this unknown, you know, for example, somebody say 5m equal to 2. How are you going to get m? The only way you can do that, you have to apply logarithm both sides or ln. But for this case, since we deal with a graph, I think it's good to go for the apply log throughout. You know what I'm saying? So I'm going to apply log here only when your power is unknown. So for me to get this unknown, I'm going to say log of 5m equal to log of 2. Is it just a notch? You know what I'm saying? It's not part of the equation. M come here, and this because it's going to come at the back. Log of 5 equal to log of 2, and then I'll divide by log 5 or divide by log 5. This goes, so my m equal to log of 2 over log of 5, and then I get the answer. So same here. If I'm looking for this, you see the power is unknown, and there's a number here which is known. So how I'm going to get there? I'll just apply logarithm throughout. You know what I'm saying? But before I do that, let me switch. If somebody say a equal to 2, no, excuse me. if somebody say, let's say 5 equal to x, I think the good way I would rather say x equal to 5. So same here, I would rather start with this one and this one go next, because my intention, I want to make subject something here. So say 3y plus 3 equal to x plus 18. And just take the group there, like switching. It's like I did here, you know what I'm saying? So this is just a note. So what I'm going to do now, okay, so you see, so we're right here. So what I'm going to do, since I want to get this, I'm going to apply log. So let me switch phase, you know? So we're going to switch. So this will become 3y plus 3, okay? 3y plus 3. Okay, so this will become 3y plus 3 equal to x plus 18. So what did I do here? It's like, look, I've taken these to the right and these to the left. It's like if somebody give you, let's say 3 equal to x. So what does that mean? I'd rather say x equal to 3 because that's what I'm looking for. So the same thing, I started with this. Can you see? This is this and this is this. Same thing. So what I'm going to do now, look. It's very, very pocket. Somebody give you, let's see, 4 power m and then equal to, let's say, 7. We say we're going to have to apply logarithm, okay? So I'm going to apply logarithm, but I must be very clever here. Look, I'm going to throughout, because I want to get this unknown. How did I say? We say, excuse me, if somebody give you 4 power m, 4 power m, if I want to get m, if this is unknown, I'd rather apply log. I'll say log of 4 m equal to throughout equal to 7. And if I want to get m, it has to go to the front, m log of 4 equal to log of 7. So divide by log of 4 divided by log of 4. You see this in this cancel, so m equal to log of 7 over log of 4. You know what I'm saying? Especially when you have a this is unknown. 3x equal to, let's say, half. So how am I going to get this value of x? Because this is unknown, I'll supply log of 3x and then log of a half. And then this x is going to go to the back. You see, you left with log 3. Sometime now, this is the best way now. Look, if I apply log, I'm going to look at this number here. Look, if this is 3, I'd rather put, I'm going to apply log throughout here and there. But that log must be under base 3. You know why I do that? I'll show you now. Because this x is going to come to the front. And here I'm going to left with log 3 under base 3 equal to log 3 and a half. Can you see? Same log, same base equal to 1. I mean, this is going to be x times 1. Because log of same thing equal to 1. And then you see, the question is done. A half under base 3. Okay? So even here, the base way, excuse me, I could have said, rather apply log under base 4 and this under base 4. You know why? Because if this m come here, and then here is going to be log of 4 under base 4, which is this is going to give us 1 equal to log of 7 under base 4. That's the best way, an easy way. So I'm going to do the same thing here. You know what I'm saying? What is the same thing I'm going to do? I'm going to apply log left and right side. So I'll say log, but I'm going to look this number 3, right? So that log must have under base 3 because this is 3 here. And then we still have this number, which is 3y plus 3 equal to log, also put on under base 3 as well. Because you know why I do this? Like I say, I want to get rid of something here. And then here we have x plus 18. Okay, cool. Now let's go. So now let's finish up this. This is not part of the solution. Right? Sometimes I write a lot of notes so that you can understand what's happening. So now what we're going to do, y plus 3 is going to go to the front. It's going to be y plus 3 means this to the front. So here I'm going to be left with log of 3 under base 3, which was introduced. Because I introduced under base 3 under base 3. And then this equal to log of x plus 18. Plus 18, I believe, yeah, plus 18. Yes. And then under base 3. So what happened? This is equal to 1. If I have a log of Mtwana under base Mtwana equal to 1, same base, same log equal to 1. So for that case equal to 1. So it's going to be y plus 3 times 1. Because it's going to be times 1 times 1 equal to same thing. Because anything times 1, that's something. So it's like, okay, let's say times 1 for the people who don't know what is happening. So log under base 3, and then we got x plus 18. You know what I'm saying? So what happened? Anything times 1, it does something. So it's like y plus 3 equal to log under base 3 x plus 18. What happened? 3 go over. So y 3 come here. So we have log 3 x plus 18 minus 3. You know what I'm saying? So that's our, what did it want? You don't want the question that define the inverse. Okay, so this is inverse of f. So finally, we say f inverse equal to log under base 3 x plus 18 minus 3. You know what I'm saying? So yeah, we got it. So now let's go to the next one. Now, you know what I'm saying? Let's go to the next one. What do they want these people? They say 1.5. So this was 1.4. 1.4. Okay? It was only this, but you know, I had to make you understand, you know? You know what I'm saying? So yeah. So now, show that this and that. These are even one. So I'm gonna raise this. I don't need this. Oh, let's write our f inverse first here. So f inverse here, because we're gonna have to use now f inverse equal to log under base 3 x plus 18 x plus 18 minus 3 minus 3 minus 3. Oh, it's too small, but I believe you understand. Minus 3 minus 3 minus 3. Okay. Okay, so I don't need this anymore. Okay, they say FO. Okay, this means take the inverse must go inside the function. So we want to prove this equal to x. Take the inverse and then put inside the f. What is the f? Is the f. So the inverse, which is there, because they say this inside f means the inverse. You see this inverse? It must be inside. It's called composition function. You know what I'm saying? It's called composition function. Oh, excuse me, sorry. Now let's go now. So how it's gonna go into function means if you take that inverse, where you're gonna put, you put in the position of x there. In the position of x, this position here. Because it's inside their function. Oh, okay. Now let's show us, please. So this gonna be 3 is 3. So in the position of x, this inverse is gonna go in because the inverse is inside. You see, is inside or within, whatever. You know what I'm saying? Now it's gonna be 3. So instead of say the x, we're gonna put the inverse now. What is the inverse? Our inverse is log, but this log under by 3, and they got x plus 18 and then minus 3. You know what I'm saying? So it's like this. Okay? So we say oh no, I'm wrong. Yeah. So in the position of x we put this, but there's a plus outside. See, this is only the position of x. So 3 is 3. In the position of x, we put that inverse. And then after that, there's a plus 3. So plus 3, and then minus 18. Minus 18 is here. Minus 18. So what we're going to do is simplify. Okay, 3 positive, 3 negative. This and this is gonna go. So this may say 3, and then we have a big, okay, x plus 18. You know what I'm saying? And then minus 18. But there's something I want to show here, logarithm rule. This rule is very funny, man. I once forgot. I remember when I was, when did I do this stuff? When I was grade 8. Okay, similar question. Not. This is very important. If you have a log, let's say log 3 or anything, let's say 2 in the log, and then let's say this is y squared or y cubed, it doesn't matter, or y squared. If this one and this one have the same number, and the answer here is whatever is there. This is one of those rules. You know what I'm saying? Means if you see these two and this is based on, this number the same, so whatever is in here, that's your final answer. Okay, come with me. How if it's like this? Let's say 7 log 3 x 2. How are we going to do all this here? A half. What about this one? No, let's put 7 here. And this is half. Can this equal to x? No, it cannot be equal to x. You know why? First and foremost, you have to remove this. The rule does not work if there's a number behind. So this half is going to go front, you know, so this is going to become 7, and the log, okay, we have base 7, and then if this half comes, it's going to be x a half. But what is x a half? It's like, look, x a half. But what is x a half? Like square root of x. So it's like square root of x. Now the rule can apply because we don't have any number behind here. So the value, look, 7, 7, and whatever in here, that's your answer. So this is equal to square root of x. So now if I come here, look, 3, 3, whatever's in here, our answer. So here, you know what I'm saying? Means, because this should be like this. Minus 18, okay. So it's like 3 power that, like this. Let me do this. See, minus 18. So this is going to give us, it's going to give us this answer here because 3, 3. So it's going to be x plus 18, but we have what? Minus 18. This and this cancel because plus 18 minus 18, so equal to x. Oh, so this equal to x. Yes, we have proved. Let's go for the next one. Last one. Actually, not next one. Last. I'm not supposed to erase this. I need this. Minus 3. Okay, cool. Okay, this is a solution here, what I'm erasing now. Okay, so now you see now, f function is inside the inverse. Oh, so what is the inverse? Our inverse is that. So we want to get f inverse and then of f. Okay, so what does that mean? It means the function now, it must come inside the inverse. Oh, so these are inverse. So what the function? This is a function here. So it must come in the position of x. So we're going to take all this stuff in here, all this function, because the function is inside. You see, it's inside the f. It's inside. How do you know inside? The front one is the one which is inside the other one. The front one. You know what I'm saying? That's the function which is going to go inside. So the front one is f, which is there. So it's going to come to the inverse. So where is going to go in the position of x, of inverse? So we're going to say, okay, so f meaning, so this is the one which must go inside the other. So we take that one into there. So we're going to have a log 3, and then the position of x, now we're going to put that stuff there. So we have a bigger bracket, that's bigger bracket, and then we plug say 3 x plus 3 minus 18, but we have what? Plus 18 because only the position of x, then you have it plus 18 and then minus 3. So this and this cancel, so this time we say log and be 3, so this and this cancel because plus and minus will be 3 x plus 3 and then minus 3. So this one does not work like how it was before. There's no such a rule here. What we can do here, we can take this to the front. You know what I'm saying? Because look, this is like a log of 3. If I take this to the front, look, it's going to become x plus 3. It's going to be log of 3 under base 3, which is going to give us 1 minus 3. Finally, okay, so this is going to give us 1 because same base, same log. So you have x plus 3, and then have minus 3. This and this, and it's finished. So x. My God. Oof. We done, man. We out. I don't want to talk to you today. Bye.